Section 4.2 of the guided notes. We are going to be using some things called algebra tiles to help us understand polynomial addition, subtraction, multiplication, and division. And so I have a set here. I'm going to pass them out to help us understand. So if you have a set, please keep the pieces all together. And the way this works is the large squares. Basically, you don't have to write this part down, but the large squares are said to have dimensions of x times x. And when if you were taking the area of this large square, right, that would be x times x. So these are equal to x squared. And these long skinny ones are said to have the dimension of 1 by x. And right, this would be like the area of the square. And 1 times x is simply x. And the little tiny squares are 1 by 1. And the area of the little tiny squares, 1 by 1, is 1. And then if you'll notice they're different colors, right? You know, one color will represent, positive numbers. And the other color, negative numbers. Now, I'd like to keep this class set largely intact. I plan to use it for a couple months. So if I hand out a set to you, to your table that is, please keep it intact and make sure it goes back into the bag for the next class so we can just keep using these things over and over and over again. So without further ado, let's dive into some of this addition. So if you're looking at these squares and having things with your hands, they call this manipulatives, and supposedly it helps you learn this stuff better. So let's give this a shot. If I have two of the big squares and one of the long skinny ones, that's the opposite color, and we're going to follow this key up here, right? How many x squareds do I have? Well, I have 2x squareds minus 1x. And if I've got the big square, 3 skinny ones, and one of the tiny ones, right, this would be x squared plus 3x, right? I mean, basically 3 of these things, right? 1, 2, 3. And then that's going to be minus 1. So far, so good. And let's move to the next page. So if you put all these together, right, you basically have 2x squareds minus 1 plus an x squared plus 3x's and then minus 1. And now if I rearrange the tiles in all their like terms, so to speak, how many of these things do I have? Right? 3 of them. And how many of that do I have? Well, that's one of them. And then how many of these do I have? 1, 2, 3. And minus a 1. And now hopefully I can identify the 0 pairs. They're like tiles with the opposite signs. Together, they equal 0. And you have this condition, right? So these basically cancel each other. They become 0. They are 0 pairs. So you simplify the sum by the 0 pair. So basically when we have two pairs that cancel each other out, we remove the 0 pairs. So if we take that out of our collection of squares and rectangles, our final answer is 3x squared plus 2x minus 1. So you can see how these algebra tiles can be a helpful way to figure this stuff out. Now, it only works to a certain point with stuff to the second power, but it is helpful. So let's move on to the next page. Or you're on the same page, I'm on the next page. Here we go. So we're going to use the vertical format to find the sum of this mess. Now you could also use your algebra tiles, right? And that would be, you'd have 9 of these things in total. And you'd have 2 of these things. One that was a different color. You'd have one of these that was a minus, and then you'd have 2 positives. But I can also set up this equation vertically, and as long as the powers, right, this x squared part line up with the x's, line up with the stuff that doesn't have any exponents, I can now add these things together. So 2 minus 1 is basically a plus 1. And then 2 minus 1, that's a plus x. And then 5 plus 4, that's 9x squared. So setting this up vertically helps you solve these as well. And if you notice from our algebra tiles, if we remove basically all the 0 pairs, what do you wind up getting? 9x squared, 1x plus 1. So now let's line this problem vertically. You have basically 3y to the third plus 0y squared, right? There's nothing in between here, between the y to the third and y to the first, plus 2y to the first, plus essentially 1 times y to the 0. And you don't have to write this y to the 0 if you don't want. I'm just illustrating how the powers of the exponents go from 3 to 1 to 0. But anything to the 0 power is simply 1. And I'm just choosing to show it for your own understanding. And so now this next one, we have nothing y to the third. And we have 1y squared. We have nothing y to the first. We do have a minus 1. So here we go. Let's add them together. 3 plus 0, 3y to the third. 1 plus 0, 1y squared. 2 plus 0, 2y. And then plus 1 and minus 1 cancel. And the next one, we're going to align vertically. Minus 6x squared plus 0x plus 2 minus 4x squared plus, there's nothing else there, right? Add this stuff together. Basically 2 plus minus 6 and minus 4, minus 10. So there's 2 examples. Let's do a few more. If I line this one vertically, I have minus x to the third plus 0x squared plus 0x plus basically 2. And there's nothing to y to the 0. And then minus 4x to the third. You don't have any x squareds. It looks like you have 1x. Nothing to the 0 power, but you do have a y. So let's add this all together. Minus 1 and minus 4, minus 5. 0 and 0 is 0. You've got 1x. You've got a 2. And you have a y. Last example. Y minus 7. 3y plus 18. 3 plus 1 is 4. 18 minus 7 is 11. So hopefully we've already done a lot of examples before you probably even seen these notes, but this should all make sense by now.